So with this question, we have a 32-bit memory address, and this will be given as a word addresses. And assuming that with this one, I'm just addressing the word. I'm not interested in addressing the bytes, for instance. I'm giving you all of these values, and I'm asking you that if you have the direct mapped cache with 16 actually blocks, each block will be one word, how basically you will define your address scheme. Since you have just 16 blocks, of course, you will just need 4 bits for indexing. The rest will be for the tag. You don't need to have any bits for the offset since you are just interested in the word. Correct? You can assume that even though the word is 4 bytes, but I'm not interested in addressing the bytes, for instance. In another sense, you have like 16 floors inside your hotel, and you have 4 rooms inside each floor, but you have decided that to combine these 4 rooms to be a suite, and you will just address the suite. So in each floor right now, instead of having 4 rooms, you just have 1 suite. So if I'm giving you the floor number, then you will go to the suite directly because you just have 1 suite in each floor, correct? So you don't need any data to specify which suite number. You just need the floor number. As soon as you arrive to the floor, you know exactly the suite. Does that make sense? With the hotel, it doesn't make sense. Yes, it does make sense. With the others, does not make sense. So continue with this. We have to create a table with all of the values that is giving 3, 180, 43, 2, and it has to be in order. And we have also to write the corresponding value in binary. All of these values. I just choose 4 data for the tag only because of the space. This is first. Second, the largest number that I have here will not need more than these 8 bits. So that gives me that all of the bits to the rest of the tag to the left will be zeros, correct? So in space, thus I don't have to write zeros like all of this time. And I know that the 4 digits, first digits will be corresponding to the index. That's why I highlighted the index as red, and all of the corresponding will be red. And then I will create a table with column index and tag. I will do that for all of this number. I will say like, hey, this 0, 0, 1, 1, this means 3, and the tag is 0. This means 4, and the tag is 11. This means 11, and the tag is 2, and so on and so forth. I will do this for all of the rest, so I don't have to go over it with you one by one. You just can do it. Then my next step is to specify which one is hit, which one is miss. And here is the idea. So how I can specify if it is hit or not? At the very beginning, the cache is empty. So of course, anything that I will first touch it, it is miss. But how I could know that anything else will be hit or miss? Since this is just 1 suite per floor, correct? And direct map. So if it is not exactly the same number, I will always miss. If I look at all of these, index 3 and 0, 4 and 11, 11 and 2, 2 and 0, 15, 11, 8, 15, 14, 11, and so on and so forth. Nothing of this has been repeated. I don't have the exact same number. If I repeat these 3 as an example here again, this will be hit. Correct? But any other than that, I'm just overwriting, or it is in another space. Is that clear? So assume we have a little bit, it changed the problem. That now, still we have the direct mapped cache, but with 2 word blocks and the total size of 8 blocks. Of course, I don't have to give you this because I'm telling you that you are using the same amount of blocks. But you have now 2 words per block. I have now decided to have 2 suites per floor. And they are the total same number of suites. So I am expecting that, of course, I will get the number of floors decreased from 16 to 8. Yes, because I have at the end 16 suites. But I have decided right now to put like 2 suites for each floor. So the total number of blocks or the total number of floors will decrease by half. This is the first. How we can address our data right now? I have 8 of these, from 0 all the way to 7. I have 8 floors, correct? In each floor, I have 2 suites, this and this, correct? So now I have 2 things to address a certain suite. First, I have to specify which floor number, and then I have to specify which suite number. Because I can give you that you live actually in floor number 0, and it did not give you the suite number, which suite you will be able to know which one is belonging to you. You need another more data in order to know that, correct? How many bits do you need to address which floor number, and how many bits do you need to specify which suite number? Of course, with this, it is 8, so log to the base 2 to the 8 is basically 3. So I need only 3 bits to specify the index. How about the suite number? Since there are 2 options, yes, either right or left. So I need just 1 bit, 0 or 1. 0 means, like as an example, the right, 1 is the left. So I just need 1 bit for the offset, 1, 2, 3 for the index. So this will be for the offset, and this will be for the index. The rest will be for the tag. Oh, so I will do exactly the same things as previously, exactly that I have to write all of these numbers in binary. But I will look at the values differently. I will look at the very beginning, or the first bit is just the word offset. Is it telling me which suite? Is it the suite number 0 or suite number 1? The next 3, it's basically the index, as you can see from here. And this will give us an indication that where exactly my floor located. The rest will be for the tag. And I will create exactly the same columns in terms of the tag and in terms of the index. So with this one, with the 3, I will look at these. The index is 1, the tag is 0. I look at these, the index is 2, the tag is 11. I look at these, the index is 5, the tag is 2, and so on and so forth. Remember that I did not touch the word offset to calculate either the index or the tag. Because I might be in a floor number, but maybe like the suite to the right or the suite to the left. The right or the left will be specified by the 0 or 1. Okay, so that is perfectly fine. My idea or my job right now is how I can calculate or specify if it hits or miss. Again, the very beginning, I'm assuming that the cache memory is empty. So anything that will be touched for the very beginning or the very first time, it will be miss. If I would like to touch the 3 with index 1 and 0, it will be miss. Index 2 and 11, I didn't touch it before, and the cache is empty, so again it is miss. 5 and 2, I didn't touch it before, and the cache is empty, so again miss. Index 1 and 0, is that hit or miss? If it has the same floor number and it has the same tag number, does that mean that it is hit or miss? First of all, I have to think about the spatial locality concept. We already mentioned earlier that if I will have multiple of rooms or multiple of suites inside the same floor, of course I will use the spatial locality. So if I were to have memory of 0 and memory of 1 in the same floor, if I need memory of 1, I will bring memory of 0 with me. So the next time that I will need memory of 0, I will find that it is hit. Or for instance, if I have memory of 0, I need memory of 0, and I don't have memory of 0, I went to bring memory of 0 from the main memory, I will go and bring memory of 1 with me. So the next time that I will need memory of 1, it's basically hit. Is that clear? This gives us an indication that if we are having the same floor number and the same tag, so this means that actually we are hit. So if you bring the same tag and the same index earlier, I will hit. And if you look at this 1 and 0, you found that 1 and 0 already brought earlier, even if the word offset is the same. Sorry, the word offset is different. Why? Because at the very beginning, you went to bring, as an example, suite number 1. Correct? But I know that suite number 0 and suite number 1 in the same floor. So when I went to bring suite number 1 or memory of 1, I brought also memory of 0 with me. So if I will need to access memory of 0 later, I am hitting. One can say that, oh, let's take that back. So why you are saying that these should have the same tag? Why you didn't say that they might have only the same index? Because if they are in the same floor number, we are basically in the same place. Why you are saying that I have to have the same tag? Because, as we explained earlier, that we are mapping many to 1, yes? A lot of spaces to the same space, correct? Yeah, I know that the first floor, for instance, or the 0 floor will have suite 0 and suite 1. And then the next suite 2 and suite 3, suite 4 and suite 5, and so on until like have the 8th floor, yes? 6 and 7, and then the last one will be 14 and 15, correct? How about 16? How about if I'm asking you where is the memory of 16? The memory of 16 is just going around again, and you will go to memory of 0. So you will overwrite memory of 0 by memory of 16. And if you look closely at the tag of memory of 16, even if they are in the same floor number, but they have different tag. So I can't say that if I had memory of 0 earlier, and I brought memory of 16, so I hit. I miss, of course, because I will overwrite the memory of 0. Does that make sense? So that means that I will always look at the index and the tag. If they are both the same, then I hit. And according to this rule, 1 and 0, I have it earlier, so with this guy I hit. 7, 11, I didn't find it earlier. 4, 5, I didn't find it earlier. 7 and 11, oh, I just found it here, so I hit. Even if this guy is word offset 1 and this guy is word offset 0. Because we are in the same floor with the same tag. So with the spatial locality taken into place, I should be able to hit. If you go with this again, 7, 0, 2, 11, oh, we have the 2, 11 earlier, so I hit, and so on and so forth. So just like, for instance, if I'm asking you from the very beginning, so you have now the spatial locality, 0 is 1 in the same floor, 2 is 3 in the same floor, and so on and so forth. How about 180? When you go to bring 180, will you bring with you 181 or 179? It's difficult just to understand it from this situation, yes? You have actually to break it down as exactly as I mentioned. And when you break it down exactly as I mentioned, you will understand. Then when you go to bring 180, you will go to bring 181 with it. Why? Because if you look at 180, and according to our scheme, it is index 2, tag 11. If you go to 181, it is also index 2 and tag 11. So basically, 180 and 181, they reside in the same floor or in the same block. The same apply with 191 and 190. I might ask you, if you were to get 191 and you are applying the spatial locality, when you bring 191, will you bring with you 192 or you will bring with you 190? Same apply. You will do whatever I just mentioned. You will search for the same floor the same tag, and accordingly you will know which one you will bring it with you, and then you will decide afterwards that it is hit or miss, and so on and so forth. So now we have the some information for our cache. The cache data size is 32K. The cache block size is 2 words. So we have 2 words for each block. The cache access time is 1 cycle. Calculate the total number of bits required for the cache listed above. So we would like to calculate the total number of bits. Oh, but one may say that, how are you asking about the total number of bits while you are giving me the total data size, the cache data size? You are confusing us. You are confusing us. Actually, if you remember with the cache, we mentioned that we will have the data, but not only the data. We will have the tag associated with the data, and we will have the validity bit. Correct? So we have the tag and we have the validity bit. But the issue that we are facing right now is to calculate how many bits for the tag. So the validity bit is 1, but how about the tag? Correct? So the tag, how we can calculate that? Before we go to calculate the tag, let's just remind you about something. That now we need to calculate how many blocks do we have. Because in order to specify what exactly the tag, I need to know what will be the offset number, what will be the floor indexing numbers, and so on and so forth. Correct? So first of all, how many blocks, how many floors do we have? I know total number of rooms. I know the total number of rooms, the data size. I know that. So how I can calculate the number of blocks? The number of blocks will be basically the total number of rooms divided by the total number of rooms for each floor, correct? What is the total number of rooms in each floor? The total number of rooms of each floors will be the number of words that I have multiplied by basically the number of bytes inside that particular word, which in another sense, I will calculate the number of blocks at the data size, which is 32K, and 32K, by the way, is 32 multiplied by 1024. 32K divided by how many rooms? I do have 2 words, correct? 2 words, it's basically each is 4 bytes. So the total number of bytes are 8. So I have to divide the total number of rooms by 8. So I will be able to get how many floors, correct? Because it is byte addressable. By default, it is byte addressable. So the total number of floors will be 4096, or the total number of blocks. I told you here analogy to floors, so you can remember. Okay, so now I know that 4096 floors. How many bits do I need for the index then? Log 4096 to the base 2. If you do that, it will give you 12. So the DAG size will be 32 minus the indexing bits and also the word offset bits and the byte offset bits, correct? So if you were like to design this guy, this tag will be the 32 minus index minus word offset minus byte offset. Since I have 2 words in each block, how many bits do I need to say that it is here, not here? How many bits? Just 1 bit. Here you can see that I have here 1 bit because they are 2. Log 2 to the base 2 is equal to 1. Byte offset. Inside each of these, we have 1, 2, 3, 4. So assuming that I specify here which room I should address, how many bits do I need? 2 bits. Yes, so we have 4. Log to the base 2 to the 4 is basically equal to 2. To 32 minus 12 minus 1 minus 2, I have 17 bits. 17 bits for the tag. Okay, so yeah, if I have 17 bits for the tag, how I can calculate the total size? The total size will be the data size plus the validity bit size plus the tag size, and all of this multiplied by the number of blocks. Correct? Because in each of the floor, I will have my data, I will have my tag, I will have the validity bit, correct? Correct? I know all of this information. I know this size is 32K. But I need to know this. In order to know this, I need to know that this is basically 17 bits. I need to know that this is 1 bit, and then I will multiply it by the number of floors, correct? So it will be 17 plus 1, 18 multiplied by the number of blocks, which is number of floors, which is 4,096 blocks, correct? So now I know this plus this. This is the total bits inside my cache. So now we need to calculate the performance of the cache, assuming that you have a direct map cache with 4 blocks, each block holding 1 4-byte word. And it is byte addressable because this is the default, correct? With these 4 blocks, so now we have 4 blocks. 1, 2, 3, 4. And each one of these has like 1 word with 4 bytes, correct? 1, 2, 3, 4. Correct? Yes? And I'm giving you this memory access 0, 4, 0, 4 repeats and so on and so forth. And assuming that this addresses is with the byte, I'm giving you the byte addresses, not the word addresses. Okay? I might give you the word addresses, or I might give you the byte addresses. Here I'm giving you the byte addresses. If I'm giving you the byte addresses, you can easily apply whatever we mentioned earlier exactly with specifying the number of bits and so on and so forth. However, with this one, with just like having 4 of these, and I don't have like a big numbers like that, so I can specify easily that this is memory of 0. Yes, this is memory of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then 16, I will override this one and so on and so forth, correct? But I don't have all this large number. And I'm asking you, the first thing I need 0. I went to 0, so I didn't find it, so I miss, correct? Then the next one, I need 4. I went to 4, I did not find it, so I miss, correct? Then I went to the 0. I went to the 0, oh, I just recognized that I just requested the 0, so I hit. How about the 4? Hit. But I'm saying that this is repeat. 0, 4, 0, 4, 0, 4, 0, 4. So I infinity hits, yes? If I compare 2 misses with infinity hits, what will be my miss rate? 0. And that's why is the correct answer. A. Is that clear? Assuming that I have this guy now, what will be the miss rate? Again, you can just like draw whatever I just had. And since you don't have like out of these numbers 0, 1, 2, 3, 4, 5, 6, 7, you don't have to go even more than that. At the very beginning, 0 is miss. 1, spatial locality. Spatial locality. Spatial locality that when I go to bring 0, I will go to bring 0 and 1 and 2 and 3. All that basically apply the same flow. Correct? So basically the 1 is hit. How about the 2? Hit. 3 hit. 5. The 5 is here, so it is new, I miss. And anything else 4, 6, 7 will be hit. Correct? If I were to add that one. 2 hit. 3 hit, and so on, so forth will be hit, 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 and so on. If you will do that, it's actually none of these percentage, and that's why we will have the F, none of these, and I showed you like what will be the miss and the hit in all of these examples. If I'm asking about 0, 0, 4, 0, so I don't have to draw the same things again. With the 0 will be miss. Again, 0 is hit, 4 is miss, 0 is hit. What is the miss rate? 50%, because 2 misses out of all 4, so I will have the 50%. And of course, the answer will not be the same if it is repeating, because if it is repeating, it will be something different. Okay, and so on and so forth. So you need to think about that as well. How about this one? So now we have the 32K, but two-way associative cache. Use 5 bits for the offset field. We know to know like what will be here and what will be here. Of course, if we know here, it will be 32 minus this minus that. So the total cache size is this guy, 32 multiplied by the 1024, correct? Each block, how many bytes it contains? 2 to the power of 5, because I have 5 bits. Correct? So this means that I have 32 rooms in each of the floors, or 32 bytes in each of the blocks, correct? So then I can know how many floors, because now I can divide this total by the number of rooms per floor. I will know that how many floors I will get. And if I do this, I found that I have 1024 floors. But the trick is, I told you that this is two-way associative. What does it mean, two-way associative? That I will combine each two to one set. So if I would like to know what will be the new number of sets, what is the new number of sets? The new number of sets, it will be basically this number of floors divided by 2. So 512 sets. Because with the two-way associative, I have combined 2 floors, it's just like one. You can think of this like that, or 2 parking spots, it's just under one set, which will decrease the total number of blocks by half, correct? And instead of having 1024 blocks, I have now 512 sets. And if I have 512 sets, how many bits do I need in order to address each set? The same things exactly. Log 512 to the base 2, it will give you 9. So now I have 9 bits. 32 minus 9 minus 5, it will give you the tag that is 8 bits.